Have you ever gazed up at the night sky and wondered if we're alone in the universe? This question has captivated our minds for centuries, sparking our curiosity and driving us to explore the mysteries beyond our home planet. Space, the final frontier, with its infinite expanse and countless celestial bodies, is a treasure trove of knowledge waiting to be unraveled. And at the forefront of this exploration is our quest for planets like our own, planets that could potentially harbor life. But why, you might ask, are we so interested in finding these habitable planets? The answer is twofold. Firstly, it's about survival. With Earth's resources dwindling and the impacts of climate change becoming more pronounced, the need to find a potential second home for humanity is becoming increasingly important. A habitable planet could be our lifeline, our sanctuary in the cosmos. Secondly, it's about understanding our place in the grand scheme of things. The discovery of life beyond Earth, even microbial, would revolutionize our understanding of life itself. It would answer the age-old question, are we alone in the universe? It would tell us that life, as we know it, is not unique to Earth, that we are part of a larger cosmic family. But the search for habitable planets is not a simple task. It involves complex space missions, sophisticated instruments, and the collective effort of brilliant minds across the globe. It's like finding a needle in the cosmic haystack, and yet we're making progress. As we reach out into the cosmos, each discovery brings us one step closer to understanding our place in it. Each new planet discovered, each signal detected is a piece of the puzzle, a clue in our cosmic detective story. So as we continue our journey into the great unknown, remember this. The search for habitable planets is not just a quest for scientific knowledge, but a journey to understand our place in the cosmos. But what makes a planet habitable in the first place? Let's delve into this captivating question. When we talk about a planet being habitable, we're referring to its ability to sustain life as we know it. This is largely determined by a concept known as the habitable zone, or the Goldilocks zone. Why Goldilocks, you might wonder? Well, remember the tale of Goldilocks and the Three Bears? Goldilocks didn't want her porridge too hot or too cold, but just right. In the same way, a planet in the Goldilocks zone is neither too close nor too far from its star. This sweet spot allows for the presence of liquid water on the planet's surface, a critical ingredient for life as we understand it. Yet being in the Goldilocks zone doesn't guarantee habitability. There are other key factors to consider. A suitable atmosphere, for instance, is vital. An atmosphere can regulate a planet's surface temperature, provide protection from harmful solar radiation, and hold the gases necessary for life. Consider our own planet, Earth. Its tightly held atmosphere contains just the right mix of nitrogen, oxygen, and a smattering of other gases. This beautiful cocktail not only allows us to breathe, but also keeps our planet at a comfortable average temperature of about 15 degrees Celsius or 59 degrees Fahrenheit. Water is another key factor in the habitability equation. It's not just about having water, but also about having it in the right state. For life as we know it, liquid water is crucial. It's the medium in which the chemical reactions necessary for life occur. Finally, factors such as a planet's size, its geological activity, and its magnetic field can also influence habitability. Larger planets can hold onto their atmospheres better, geological activity can recycle essential elements, and a strong magnetic field can shield a planet from harmful solar winds. As you can see, it's a delicate balance of conditions that makes a planet habitable, a balance that we're fortunate to have here on Earth. So, where have we looked for these habitable planets and what have we found? As it turns out, the hunt for these celestial bodies is a delicate and intricate dance of science, technology, and yes, a bit of luck. Our scientists have devised several methods to detect these so-called exoplanets, planets outside our solar system. The first method we'll delve into is the transit method. Imagine you're watching a far-off star through a telescope. Now, every once in a while the star dims slightly. This tiny flicker could be a planet passing in front of the star, blocking a minuscule amount of its light. The Kepler Space Telescope, launched in March of 2009, has used this method to identify thousands of potential exoplanets. The second method is radial velocity, or Doppler spectroscopy. It's a bit like listening to a distant symphony. As planets orbit their stars, they exert a tiny gravitational pull, causing the star to wobble ever so slightly. By observing these wobbles, scientists can infer the presence of a planet. This method was instrumental in the discovery of the first exoplanet orbiting a sun-like star back in 1995. Now let's talk about some of the notable discoveries. The TRAPPIST-1 system has garnered considerable attention. Discovered in 2016, this system houses 7 Earth-sized planets with 3 in the habitable zone. It's a compact solar system with all planets orbiting closer to their star than Mercury is to our Sun. But the star is a cool, dim red dwarf, making conditions potentially right for life. Our search has been anything but futile. We've uncovered a universe teeming with planets. To date, we've confirmed the existence of over 4,000 exoplanets, and there are nearly 3,000 more potential planets waiting in the wings. The variety is astonishing, from gas giants larger than Jupiter to rocky worlds smaller than Earth. Our search has revealed a universe teeming with planets, some of which may even be habitable. What if I told you that one of the closest habitable planets to Earth is a mere 4.2 light-years away? Yes, you heard it right. Just over 4 light-years away, in the Alpha Centauri star system, resides Proxima Centauri b, our nearest known potentially habitable exoplanet. First discovered in 2016, Proxima Centauri b quickly captured the interest and curiosity of scientists and stargazers alike. This exoplanet, which orbits the red dwarf star Proxima Centauri, is approximately 1.3 times the size of Earth and has an estimated surface temperature that could allow for the presence of liquid water, a key ingredient for life as we know it. What makes Proxima Centauri b particularly exciting is its location in the so-called habitable zone, or Goldilocks zone. This is a region around a star where conditions might be just right, not too hot, not too cold, for liquid water to exist on a planet's surface. And where there's water, there could potentially be life. But it's not just the potential for water that has scientists buzzing. Proxima Centauri b also has a year that lasts just over 11 Earth days, meaning it orbits its star quickly, and this could have interesting implications for its climate and weather. However, as with any scientific discovery, there's still a lot to learn about Proxima Centauri b. Its proximity to its star could result in intense stellar radiation, which could pose challenges for potential life. And while we're not packing our bags just yet, the discovery of Proxima Centauri b has certainly ignited a spark of hope and a sense of wonder. It's a reminder that the universe is vast and full of possibilities, and who knows, maybe one day we'll find that we're not alone. After all, with billions of stars in our galaxy alone, the odds are in our favor. Proxima Centauri b, our nearest potentially habitable neighbor, gives us hope that we might not be alone. What does the future hold for our search for habitable planets? A question that piques the curiosity of scientists, space enthusiasts, and dreamers alike. As we look to the cosmos, we are on the cusp of technological advancements that will propel us further into the unknown, and bring us closer to answering this question. One such advancement is the James Webb Space Telescope, or JWST. Slated to launch soon, this marvel of modern engineering promises to revolutionize our understanding of the universe. Equipped with a mirror over 2.5 times larger than that of the Hubble Space Telescope, the JWST will be able to peer deeper into space and in greater detail. This could potentially uncover habitable planets that have so far eluded our gaze. But our exploration isn't limited to telescopes. The next generation of space missions aims to send humans further into space than ever before. NASA's Artemis program, for instance, aims to return humans to the moon by the mid-2020s. This is not just a nostalgic trip back to our celestial neighbor, but a stepping stone for even more ambitious missions. The moon will serve as a proving ground for technologies and strategies that could one day take us to Mars, and perhaps to other habitable planets. In addition to government agencies, private companies are also joining the race to explore the cosmos. SpaceX's Starship, for instance, is being designed with the bold aim of making life multiplanetary. This reusable spacecraft could drastically reduce the cost of space travel, potentially opening up the stars to more than just a select few astronauts. The future of exploration is a thrilling prospect. We stand on the precipice of discovery, armed with new technologies, and fueled by a relentless curiosity. As we continue to explore the cosmos, who knows what new worlds we might discover, and what new questions they might raise. The universe is vast, and we are just beginning to scratch the surface of its mysteries. So, let's keep looking up, shall we?